I'm storing it, and it is a hell lot of data. Like until and unless I cannot find the right data, or I cannot get the right data, or if I have the data but I don't know how to use it, or I don't know like how can I get the knowledge out of it, that data is just simply the bad data for me. It doesn't make uh, any fruitful inputs. It's not giving me fruitful inputs, and I cannot take the good decisions. So as a systems like in the few years back when the concept called as a database evolved, that time like it's like the purpose is to store it somewhere, and that's where, like, for example, Excel file, or for example Microsoft Access. Um, so it's the even the word file of matter of fact, like, so we are putting the content into that application and storing it in the computer. So in another way, it's the data we are just saving it a simple format. So Excel is also a one type of data that I would definitely say it, but it has a limitation. So if you go the Excel from the left to right, it has a like limited number of columns, and it has a limited number of rows. So Excel cannot give me the if cannot give me the greater flexibility if I want to store a good amount of data. So I go to the Oracle, or I go to the DBMS systems, and that's where this whole database they exploit. As my data grow, as I want to like have the scalable solution, those involvement came started along the way. So any organization, they always have two types of database. One is OLTP, and another is called as a OLAP. It's nothing but the data warehouse. It's today's topic is all about. So for example, if you go to the, let's say you go to the ATM where you withdraw the money, you insert your credit card or debit card, and then debit card get validated. You enter the password. It also get validated again, and then whatever the amount you request, that request goes to the server. It will check whether you have a sufficient balance in your account. If you have the balance, then it will give the money back, and then immediately you get the message or the receipt that your money get withdrawn from your account, and this is your balance. So let's say this specific system is malfunctional, then your whole business would be collapsed. It would be the bad point for the business as well. It's not good for the customer as well. So that it need a high accuracy. It need the high performance optimization where it can store that data quickly, and it can give the retrieve the result very quickly. So it's called as a OLTP database, that behind the every ATM or behind any interface which you day to day use it, and it is used for tracking of the event or transactional data. So simple, if you log into your Facebook account, if you log into your Instagram account, so the moment you log in, your profile get uh, uh, go on a primary screen to your whatever the device you use, like laptop or the phone or anything. So it immediately comes. So the authentication that happen in the OLTP, and then whatever the action that you do, maybe like you subscribe or anything like that, so that every single click on the device, it generates a lot of data. So the challenge is that I need a fast performance data, this OLTP. I need the fast response time. I need the data integrity. I need a good referential integrity, and my database will not be um, like like distract my constraint. So I need that good constraint and indexes on my database. So it's called as OLTP, and that's what you guys might have learned in your academic as well. So how this OLAP system is different than the OLTP. So the OLTP is required for transactional purpose, but the OLAP it is required only for a business intelligence purpose, and that's what I started the concept with. So if I want to like how my historical data to be stored, so better data or time span I have, the better historical data I have, I can take the major decision or better decision out of it. So why? So as I told you, the example of ATM, right? Like the ATM has like chip insert, the I mean data get updated, data get copied, data get updated, deleted. Everything, every actions is like happening in a couple of seconds. So it's need ER modeling where like you define that relations between a lot of tables, and that table and the indexes, and that give you enough flexibility to make it very fast. But our OLAP is not designed for that. Our OLAP is designed for to give or store the historical data. And whenever I ask, like, hey, tell me my last 5 years of sales. Hey, tell me my one of the popular product that my company has. Hey, tell me like who is the better performing employee of my company. Hey, tell me about my the geographical locations and the product sale for each locations. So those many questions I may have. So like for example, in case of DMart, like so DMart has a lot of variety of the things that they're selling out, and they have a lot of stores in diverse across the locations. So how they want to like take decisions, like for this specific locations, maybe one product is very popular, so the demand is more, so they can provide supply there. So until and unless they cannot go and check the historical data, then they cannot drive that decisions. So to make the historical data, I don't need to put it into OLTP because I don't want that to be accessed very significantly. That in case of ATM, but that can be slowed down. But I need a large amount of data to be processed. I need a good computation or good storage capacity, and that's what the OLAP came into picture. So whenever I term use the OLTP, it's all about the storing the transactional data. And whenever I use the terms, it's called as OLAP. So it means like online analytical processing engine. So that means it's all about the historical data. So in short, in summarize, so my OLTP is required to run my business because I need to store the transactional data somewhere. So whereas in other side where there is OLAP, so I need the OLAP data warehouse to optimize my business, or I can drive that actionable insights, or these are the inputs that data can give me the inputs for better decisioning. So it's optimizing my business. That's the major terms there, major difference in between two. So what is like database or data warehouse? Like so whenever you use like the OLTP, so these are our enterprise databases that has a relational RDBMS like Oracle Server Engine or Microsoft SQL Server or MySQL or Postgres or Teradata and all these like different DBMS systems. These are our databases, um, and these are the different like tools. So same applications we are using for developing databases as well as the data warehouse. So only the terms, their difference is in terms of like the storage capacity, cost, the methodology, and the purpose. Uh, I'll just quickly go over like data warehouse like is a pioneer of this concept. Is uh, at the first time like it was tossed by the some IBM researcher, and the Bill Inmon was another person who has presented that his paper, and he explained the data warehouse ecosystems and why the data warehouse like in what way we want it. Like we want it like subject oriented. So I want it for analytical purpose. I want it integrated. So a lot of data is coming from different systems. So it is more integrated. Non-volatile mean like I want it for last couple of years and the time variant. So as the time goes, the data gonna increase and increase incremental manner. So the size of the database house will increase. So these are some basic properties of the data warehouse. We can go deeper into that. So what is the data warehousing? So the technique of creating this data warehouse and make it is functionalized and create a good outcome out of it in terms of the analytical or BI reports. The whole process is called as a data warehousing. So for example, for one company, like let's say it's a logistic company, so they have the they have the couple of departments in that company. So that company departments maybe like they have the finance department, marketing, sales, accounting, management reporting, engineering. So they have a lot of different departments and lot of their application and user interface, or the departmental people generating a lot of data, and they are using the computer. So they're generating a different variety of data in across all their databases. So how that company manages that thing? So they, for each department, they create a dedicated OLTP. So where the each department persons, they can store the transactional data sets there, and as and when required, they can take the backup out of it. But now, if for executives like me, like I'm maybe like in the management body, so I need to look after for all the departments and the health of my overall company. So if that data is diverse between all these departments, like maybe 7, 8, 9, and for I have the questions like, hey, tell me like how is your sale going on? Hey, tell me the what is the marketing expenses we are putting for our product. Hey, tell me the our like balance sheet. Give me some engineering products. What's going on there? So I may have, as executives, I may have a lot of questions to ask them. So so what I do, like in that way, I develop an enterprise data warehouse, so which will be uh, based on the transactional data that we're going to have in all these databases, and I'll put it into the one single point of storage. That's the big storage, and I put the data there. So once I have this multi-dimensional data or coming from the different heterogeneous systems, I can marry that data in the data warehouse, and then I can make it good structure there. And then whenever executives ask the questions, their engineers, data scientists, data analysts, or BI developers, and all those people, they can help me to drive the conclusion out of the data that's stored here. That's the purpose. So the history of the data warehouse, like this was, like, as I told, like this concept tossed by the IBM researchers. So they put the paper as it's called as information warehouse. So uh, I mean, more than two pioneers of this data warehouse. So one is Bill Inmon. So he also presented the data warehouse ecosystems, and as well as same time in the same era, like Barry Delvin and the Paul Murphy, they are the one who first came up with the concept of information warehouse. And the Raphael Kimball is another pioneer. So he is another pioneer who presented a lot of concept how we can develop a good data warehouse and all those. So what is dimension modeling? So you might have worked on the your entity relationship diagram. So where you create your database based on your purpose, based on your business, and then you connect that database between the couple of different tables, and you apply the normalization form 1NF, 2NF, 3NF, 4NF, BCNF, or all those, right? So it's called as interrelationship. But in case of uh, OLAP, we don't want that read write great performance because data size is large. And if you split up that data into a couple of chunk and we establish the relation, it make the performance slow down. So it's basically like um, you're finding the book, you're going in the public library, and then you're trying to find the book where the books are not organized. It will create a problem to you. If the books are organized by department or by topic, it will be easy to understand to get that quickly. So, so sometimes if your data size is too high, I mean, is that your data size is too high, you make some regrouping together. So you don't like bifurcate that group into small chunk, because that will also slow down your performance. So more your data, then you push the normalization. You take the some normalization form away from the data and you put some denormalizations so that your data will be intact and get the more outcome out of it. I can explain that in a few couple of examples here as well. Uh, So whenever I design the OLTP, it's called as the entity relationship model. But whenever I want to develop a data warehouse, I use the data modeling. Data modeling is a technique, or it's a procedure where I go and define the data warehouse based on my subject matter. Okay, sure. So in the dimensional modeling, whenever I'm deriving or designing my data warehouse, what are the things that are important for me? One is the process. For what purpose I'm going to use my data warehouse. Then what is the granularity? Means like, what is the granularity? Means like what is the time frame of data sets, or how many years of data set I want to store? Maybe it's yearly, quarterly, monthly, weekly, or for I want to store the data for maybe for another couple of years back as well. So I need to decide that what kind of grain like I want to go with that data. Then the third one, like I need to decide what are the facts. So what I'm gonna measure out of that data, and then what are my dimensions. So for example, so based on the total sale, if I want to derive the sales as a measure, I want to count that for each product, for each location, what is my sale of my company. Then, so each single entity which has its own nomenclature or it has its own feature, those are not changed. So those things are called as a dimension. And whatever the numeric field that I'm gonna get out of it based on the dimensions, we generate the transition data, and that I'll join it together, and it's called as a measure. So fact table in my data warehouse is the main big table that I derive, and that gives me the numeric value out of it. So that's called as a fact level table. So for example, for dimension, like it's a location. So location is like India or the couple of states and then cities. So it never change. It may be updated, but it's not that frequently because it's not the transactional data. But these are the data who generate the data, transaction data. So for example, the people or person, so their name, their profession, their phone numbers, or any Aadhaar card number, they don't change it like as the time goes. So those are some sort of like fixed properties for them. So those are the dimensions. So it is just another example. This I wanted to show you. Like, so whenever I have a couple of dimension, I can derive a different measures out of it. So I can derive the sales. I can derive the maybe the returns. How many returns? Like if I using the Amazon, like how many returns came back, or I can get it out of its the inventory as well. What is the product is my warehouse? How many quantity of it? What is the quality of it? Like what is the cost that is associated with that product? So I can derive that based on the inventory as well. But for deriving all these fact tables or deriving all these measures, I need the dimensions like customer, date, product, channel, promotions, and all these. If you see, these are coming from a different department. Maybe there is advertisement department in my company. They are running the promotions. There is people who are in manufacturing. They are creating the product. They're handling the product department. So they might have their own OLTP. They're generating a lot of data. So all these like as dimensions or different like departments, they're generating a lot of data. So based on those transaction data, I'll see what is the helpful or useful dimension for me to derive the measures that I'm interested in. So for example, for inventory, I don't need to go with the customer because if I go with the date and product, that will give me the measures. So I'll decide in that way. Uh, so let's go back. So your OLTP looks like this because it's more normalized data sets that you apply a lot of normalization form because your read throughput is more there. You need a quick response there, and it shouldn't be create any sort of like it will not break any constraint. But in case of dimensional modeling, you always make it denormalize so that all your entities that is required to achieve your measure, that you can have it in one single table. That's what you can derive it uh, effectively, because this data is non-transactional data, it's historical data. And this is where it's a transactional data. So let's discuss about the data structure. So you might have learned about the data structure in C++, Java, or database as well, like why it is important. So data structure is nothing but you give the structure to the data and you tell how the data need to be stored and what should be the relation should be on that data, what should be the rules to access that data, or what should be the rules to write the data or update the data. So that's nothing but the data structure. So as I told you, like the OLTP is a transactional, so it's a more normalized. That OLAP is not. So it's a denormalized data set. So generally, on an average, like in the overall industry, they always go with the 3NF, where they remove the duplicates. They don't need to worry about much about the referential dependency. So they remove that. So they push some sort of duplications in terms of the number of rows, but they always uh, try not to make it like split that data into a couple of different churn in or couple of different tables. So for me, like if I'm deriving the measure out of the data warehouse, I have the time, branch, location, and item. These are the different dimensions. So I can make it very simplified. So I can make my fact table at the center, and I'll just connect all these independent dimensions, and I connect that with my fact label by the primary key and secondary key. So each primary key from my dimension would be an attribute for my fact table. And that's the reason whenever I want to see the cell for each branch, I can get this branch ID and get that result. If I want to see the cell for each location, I have the location ID and I can get the non-transactional data, that is static data from here, and get the result. I can see that cell by the total dollar amount that I spent. And also I can see the cell by the units sold. So this is star schema is very easy to read because I'm just passing the primary key of each dimension table, put it into the fact. So it's giving me a lot of good flexibility, and it's a very simple model to develop in the data warehouse. There is another data structure that they can go with is a snowflake schema. So here, the fact table means is my measure is at the center, but it has a dimension across. But those dimensions also have some sort of other tables to be connected with. So in this case, like the item, I have the supplier key, and the supplier is another table that is joined with the based on the primary key and the secondary key. But this supplier table is not directly joined with my fact label table. So this sort of like data structure is called as a snowflake schema. So let's discuss about what is this metadata. So whenever I develop the data warehouse, there are a lot of things comes into place. So maybe I have a lot of heterogeneous systems, means the different departments have their different databases. So I need the information. So I need the information from those, like for those OLTP. So what is the data they are storing? What is the size of it? What is the schema that they have? What are the tables there? What is the primary key, secondary key? What is the relationship there? So I need to know the information about each one of the field that is going in my data warehouse, because data warehouse is a large concept where lot of OLTPs and a lot of like these operational databases are involved. So the metadata is nothing but is the data about the data. And metadata generally can be stored in the table itself, whichever the table you're working for data warehouse, or that metadata can be stored into the your Confluence pages, means like your cloud pages. So whenever you join the company and they put you, yeah, whenever they put you in a like any data role, and as a new freshers, if you don't know anything about what is that database is all about.
Who is disturbing? Students, please try to understand the concept what he is explaining. Don't disturb.
Okay, yeah. So this metadata is very important as a you're beginner, because uh, whenever you go in the industry, like there's people are not going to give you the information for each single table. As a bachelor, when you pass out from the computer science field, it's always like they give you the metadata in your hand. Whether you are a developer, whether we are a data analyst or business analyst, or you're a freshers, they try to like ask them to read and try to understand by yourself. So that metadata give you the information about how your tables are get connected, what are the different tables and what are the information, the information of each single column that is part of that table. So it gives each and single information about each simple and granular field. So it can give you the data type, it can give you like why this field is important, what are the expected values in that field, uh, what is the minimum and max, what is the like accepted values in that field, like that, like all sort of information that present in that data metadata. So metadata is one of the important uh, eco. I mean, it's one of the important like points in when you develop the data warehouse. So now we see like what are the development approaches for the data warehouse. So this I got it from the some random like Google search, like, but this is very good. The good explanation or good like points that they have put it here. So there are a lot of different industries like airline industries, the banking industries, healthcare, investment, retail, telecommunications. So all these industries, uh, they are taking a lot of decisions every single day or every single quarterly, and they have a lot of product that goes to the customer hand. They have a lot of big revenues, and they have a lot of customers that they uses their services and the product. So what different strategies that they have in place, why they are using the data warehouse? So that's what I got a few examples. So for example, it's the airline industry, let's say any Spirit airline or any airline that we have, Indigo and more. So they have the functional areas, means like they are primarily using the data warehouse for operational purpose or marketing purpose. So strategic use would be like crew assignment or the pilot assignment, like you're going with that flight on that flight, like that. Uh, then yeah, and then deriving the route probability as well. So it's called as air traffic controlling. In the banking, they might have the operational in terms of the balance sheet and loan or debt that they have, the promotional that they are running out, what are the customers they have. In the retail chain, like I said, ma'am, if you can, I think this Arun is, I think he's unmuting again and again, I guess. Is there any way like to mute him? Yeah. So the demand chain that we have right now in India, they are using the data warehouse for their lot of different purposes. And what is the value that they are getting out of the data warehouse? So they are getting the trend analysis. So they can know like what is the popular product that they have, what is the popular store that they have, what is the demand and supply throughout the India. By the depends on the geographical location as well. What is the buying patterns? So for example, like nowadays in USA or in India as well, so they go with the sentimental analysis as well. They go with the deep, it's called as a like market basket analysis as well. So for example, I can give you one example. So whenever you go to the any store, grocery store, to buy a milk, and how likely you can buy cookies or biscuits or maybe some sort of snacks with that along with the milk. So they can predict that. And if you see that here in the USA, they have a lot of grocery stores. So each single thing that they place inside the store, they studied it. Why we want to keep the like all the milk section together with the curd and all, and as well as whenever the milk section is there, next to it we can keep the cookies or biscuits or any breads like that, so that because um, there is a high chances that if any customer is coming for milk, he's likely to buy the other products as well. So they do that sort of like sentimental analysis as well. So and these major stores or different malls, like they always do that analysis, depends on the historical transaction that any customer have created. In the telecommunication industry is also same thing. So they always decide about the like messaging pattern for the customers, like what is the heavy usage customer is doing for. If the telecommunication industry is providing the internet, they also give you the different offers based on your usage. So they do the personalized some sort of analysis on your use, or they kind of know if it is a metropolitan city, like most likely the people have the all over the internet access, so they most likely they're gonna use it for social platform or for educational purpose or like that. So they based on that historical data, they give you a lot of promotions or advertisement or a lot of different plans you to subscribe for. So these are just different example where like how the data warehouses and their strategies, what is their use that a lot of these different industries are using for. So there are development approaches in like divided into four types. Like I can define the data warehouse like top down or bottom up or hybrid approach or federated approach. So what it means like, so whenever I design the data warehouse, this thing, so all the data that came inside the data warehouse is coming from the lot of heterogeneous system. So that heterogeneous systems like may have like one system may have in a JSON object, or they may have the Excel file, or they may have the Oracle, or they may have in like any Teradata or in the cloud computing. And their file format is also different. So a lot of this heterogeneous system, when they push the data into warehouse, I sort of like make it sort of like having the transactional. So I put the data in the staging, and then I create a warehouse uh, based on my star schema or snowflake schema, and my warehouse it stored all the historical data. And based on my need, let's say I'm doing the data analysis. I want to put like a lot of reporting, BI reporting for specific for sales purpose or for finance purpose. I can dedicatedly get the subset of historical data sets and create my dedicated a, a data warehouse. Again, it's called as a data mart. So data mart is the step that came after the warehouse. So what is the approach? So I have the different department, and they have the different OLTPs, different operational database that they have. So either they can put all the data at the central location into data warehouse, and then they can develop the data mart. So that's the one way. Or I can create a data mart, specialized data mart based on my OLTP, and my data marts will come before the warehouse. So that is my another approach. So it's a top down versus the bottom up. So it's really between the how you switching between the data mart or data warehouse. So data warehouse and data marts are, again, these are the OLAP system. This is used for analytical purposes only. Their usage and their complexity is little more and high, depends on how you're gonna use that OLAP system. And whenever I have this data marts or the warehouse, uh, my end users are for reporting, data mining, data scientists. So I can do the trend analysis. I can predict for the business. I can get what is happened in the past, or I can get and I can take the decision based on the past data that I can see, and I can get decision for the future. So all these things, the analysis or study gonna happen by these different users, and this data is being used for the executives for their decision making system. This is another example where I'm just showing the different departments. Like the data marts is another the major or fact that we are encountering for the warehouse. So in this setup, whenever I create the data mart, the profit is, I mean, the benefit is I will be having a single point of contact here. If my data change it here, it will change it here. But I don't need to worry about the second fact check for my data, because all the data in all my organization gonna come here only. So this will be a single proof of data for me. So data mart is just specialized data warehouse and OLAP systems that I told, and then that can be use it for another time frames, like maybe daily, weekly, quarterly. I can define the way that I want, what is important for my business. So let's learn about like what is this ETL and ELT and where it plays the role. So in my whole data warehouse, I joined a lot of heterogeneous systems with my OLAP system. Is I create the data warehouse. So I take the millions of rows that have the transactional data have. I get those and I put it into a structured format into my data warehouse. So it's a heavy lifting. It's a require the heavy computation in terms of the resources, in terms of your uh, competitions, the API interfaces versus your extracting information, you're transforming, like means like, for example, you want to add some few values into your data while storing it. So it will be like transforming, or you want to clean that data, or you want to like change the data type of it, because this heterogeneous system, they have maybe like there is a one entity has a different data type in one database. In another database they have the different data types, so they may have the heterogeneous different data types as well. So for a single entity, if I want to put that single entity in the data warehouse, I need to make sure that the data type is same for that. So those sort of data cleansing, the transformation, a lot of things happen, and that's what is called as a ETL. It's a pipeline. So what the ETL pipeline does, so I have this heterogeneous systems. So it's connect with my data warehouse, and this is the middle layer. So I extract the information from these multiple data sources. I transform it the way that I want. I make it cleans, and I add the additional fields to it, and then I load into the data warehouse. So this will, I can do it as a batch processing. So whatever the ATM transaction happen in a month or maybe in a weekly, so every week at the end of the week, I can run my ETL job and load that data from OLTP to my OLAP system, and I can cleaned out my OLTP because I need to run it fast. The another concept is a new evolvement. It is new concept for modern data warehouses, where they're saying is ELT. So where I don't need to transform the data first, but what I'll do, like I just extract the data, I just load into the some common staging area and put it into data warehouse immediately, and then as and when required, I'll transform it. So why this is important, like ETL versus ELT. So ETL is a traditional way. So because I have the data coming through from the structured databases, relational databases, so I have the time to make it transform and put it into load. So think about the social platforms nowadays, like Instagram, Telegrams, and all this Facebook post, and a lot of YouTube bloggers, their comments, their tweeting, their subscription, and all those things, pictures, media, videos. So they have a variety of data that's going by for each second, and maybe one customer are generating like maybe a couple of thousands of rows each day if he is a heavy user. So if it is variety of data, then and whenever I'm keeping that is an OLTP, that would be expensive for me. So I need to, as the data get generated, the data size is more. So as the data generated, I need to get the data and load it somewhere. So I will not I will not lose that data. And as and it required, I'll make it the transformation later in the stage. So whenever there is a data size is more and your data has a lot of variety of data in it, and your retention policy on that data is also less, and also due to the size, you cannot manage that data into your OLTP because it will slow down whole things, and customer will not get a proper response out of your website or out of your app that you are using. So that is very important. When the data is streaming continuously, then you need to make it load it first and then transform it. So this is ELT concept is for current data warehouses. It's called as a cloud data warehouse. It's coming up in the future. I mean, now in the market. So this ELT concept evolved based on the new trends or new era that we are going into. So again, so ETL is like establishing the pipeline and moving the data from one point to the other point. That was ETL. The end result for each warehouse, it can be for alerting, for dashboarding, for generating a report, creating visualization, data mining, or OLAP analysis. I can use that data for all these purposes. And this has the value because until and unless I do not have these different things on the data, I cannot optimize my business. So now is concept of data mining. So data mining is a very major concept in the field of data warehouse, because that's the one of the prime purpose that we create a data warehouse. So how the data mining help us? So data mining is nothing but the technological stack that we have. So if I'm accessing the data from one Excel, I can just quickly open the Excel and get the data out of it. But let's say I have the billions of rows, so my Excel cannot handle that. So I need to put it into maybe some sort of data warehouse, database. If I'm using SQL on the database and my data go into petabytes or more than that, my Oracle, traditional OLTP gets slowed down. That cannot be handled through the simple SQL. So I need to go to the higher level up. So I need to use the programming languages. So maybe I can use the Java, I can use the Python, or I can use the C++, or PHP or anything that I'll join that line. I'll create some sort of program that can connect to my data warehouse, database, or data ODS system uh, that extract the data, make some sort of computations, uh, because now I have the size is in continuously increasing. So I need to use the technological stack that is capable to handle that sort of variety of data or size of data. So as my dataware or database size grow, I need to go with the higher end technologies so that can facilitate or that can run very fast. So for example, For NASA, whenever they launch the satellite, for every second they need to do thousands of calculations. So that cannot be done with your traditional computers that we are using, right? It may be the high-end computers, or those are the supercomputers or mainframe computers. So each single seconds they are doing the thousands of calculation, because those is higher end super computations capacity that those hardware have, or those application or software have. So whenever I have those sort of client server architecture, or I'm using a supercomputer or mainframe computers, I need to use the technologies that can give me better result there. So that's nothing but the data mining. So data mining provide you the technological stack. It provides you the sophisticated approach to get that data from your data warehouse, apply some sort of algorithms, and get the good result and good the meaningful actionable insight out of it. And that can help you for predictive analysis. For example, for whenever weather department, they generally do the past studies for a couple of years, and then they derive how likely the rain gonna come, how likely the tornado gonna come, how likely the water levels of all the rivers or ocean can go uh, when there is some sort of calamities are happening. So they have this prediction capacity or prediction capability because they analyze data through the data mining, data mining tool, and then they uh, did some sort of probability out of it, and they are taking decision out of it now. So they have studied those things, so they established some sort of rules, and those rules are helping them to drive the conclusion, and they are taking the better decisions, so they are giving you alert whenever something bad gonna happen. So data mining, you use different data set, you process based on the different data algorithms, like bubble sort and all those algorithms as well, and some data science algorithms like regression analysis and those different models. I use it, random forest and all those sort of algorithms. I do the classification. So uh, if I want to calculate my populations of my country, like I have the uh, men, woman, and then I have the different age group. Then I have the different ethnicity. I don't have the different race, caste, religion. So I can classify the data in based on the different component here. So data mining can help you in that way as well. So data mining, we use it whenever you have the data warehouse or cloud systems, or you are doing some data science or prediction analysis. So this is the concept that help you uh, to to facilitate in that sense. So data mining is a small subset of data science, and these are the different. I just give the example, but sort of like I gave you like. So for example, when I have the banking as my industry, then uh, to overcome the credit card fraud, or to overcome the loan fraud. So I need to do some sort of intelligence, the machine intelligence. I need to put it there, so that can help me to overcome my losses in my financial thing, and that will give the good customer experience to my users as well. So fraud detection model is one of the example of data mining, and same case with the as your industry type change, you develop a different sort of models, and they'll give you different values there. So I'll go with this. So in summarize, so data warehouse giving you the capability to memorize all your data, past data, and the data mining provides the the enterprise with intelligence. So data mining enable you to do the intelligent, derive the intelligent outcomes using the data warehouse. So how the modern data warehouses and data lake are growing up in the current industry now. So a lot of industries nowadays, like Facebook, Twitter, Airbnb, or Amazon, all those, so they generate a tons of data, like petabytes of data, maybe for in a few couple of hours. So for them, storing data is expensive because more data, then I need to increase or scale my storage location. So now Facebook or Amazon or a couple of industry, they're establishing their data warehouses in a cold location because a lot of computation happens, a lot of heat get generated, and that may damage to all your hardwares as well. So the cooling mechanism, then the security of the data. What if like the failure come, then you would uh, most likely will lose the data. Am I audible now? If anyone can just say yes.
Yes, sir.
Okay, perfect. I just got the message. So okay, so now these different industries, so they are establishing their data warehouse where there is a cold environment. So they're taking the help from the nature as well. Whenever there's a cold environment, that will help you to reduce the heat get generated from their high-end hardwares as well. So it's a very expensive operations for all those industries nowadays. And to maintain one data warehouse, they need a lot of workforce. They need a lot of electricity consumption, the power. Then they need to uh, make sure that if something happen, then they have the backup of that data. So that fault tolerance also needed to make sure that data will not be lost. So all due to considering all these challenges, so these new concepts are coming up. They're using the cloud computing to designing these modern data warehouses. So till few years back, we were not having the technology or we were not having the knowledge that this data will be very prime, and that is very important to drive your businesses or to overcome on your terrorism, to take the country's good decisions, uh, to do some public welfare decisions as well based on scanning your like historical data. So and then all these social medias are now coming up, so they are also generating a lot of entertainments. Then this YouTube, they're generating a lot of video contents. Those are the big size in the data. So and this social media, they have the variety of data as well. So they have the text, they have the images and all those things. So due to these things, so the traditional data warehouses also is having some challenges. So they want to make it scalable more, because more your data store, more you need to scale your all the hardwares. Otherwise your performance will be derailed, or you need to increase your storage size, or you will lose the data. So considering all the challenges, they come up with the modern data warehouse concept, and data lake is one of the new concept in the field of cloud data warehouse. So data lake, uh, what it does, like, yeah. So the data lake is the thing where your data is coming in the flat files or some unstructured way. So you store that as is, like a data warehousing or data modeling. You don't do the transformation of data, but you make sure that data, yeah, you stored in a file. That file may be the JSON object, or that file may be the arrow, or that file may be the CSV, simple CSV, or maybe Excel file. You just, as the data come, you just store it. Um, and you're using the cloud system, so you don't need to worry about the scalability, because as the you're running out of the storage, you can just ramp up another storage or competition quickly. Uh, so these data lake are using the cloud computing ecosystem as well as the data warehouse concept. And this is the new architecture or new era where we are right now. And a lot of industries are moving their data into data lake now. So, and this data lake has the capacity to handle any different types of files, a variety of different data types, and variety of different file formats that's coming from heterogeneous systems. They have the capability where you can scale the hardware as and when it required. They also have some high-end cloud computations that they mount on the top of data lake. So those are capable to handle and compute that data, and that's being used by the analytics scientists and a lot of machine learning engineers nowadays. So this is the new things that has a lot of job opportunities, and many of high pay job they're generally ask about this concept. This is the technology stack that I'm just one of the companies use it for their data lake, building data lake. So you might have heard like now the AWS has the major share whenever there is a cloud services come into picture. But the Google also have their cloud platform, and as well as the Microsoft also have their Azure as a cloud platform. But Amazon has a biggest share throughout all the countries. Then there is the integration tool. So these tools are helping you for ETL or data migration purpose. Then you have the analytical school. You might have heard about the Tableau. So these are the tools giving the capability to derive visualizations. So those visualization will be interactive. So because when, as a data expert, when you derive the insights from the data, uh, the executive may not understand that. So you need to present that data in some a good visually way, so that it's easy to understand, and you can show that trend, or you can present that trend to the non-technical people as well, or business people, so they can get a good value out of it. So that's the reason, like a lot of, I mean, in the current days, like these analytical tools are getting a lot of popularity, and a lot of new companies also coming up now. The storage wise is so, like as I told, like the now this modern data warehouse are using the concept of cloud. So they are overcoming the storage problem. So they are going with the cloud storage services. So let's say like I subscribe for 500 gigabytes of size. If I'm running out, I can quickly buy it, and they'll giving that uh, space, another additional space to me, and I don't need to worry about running out of the space and worry about losing of any of other data. So these are giving facilitating more scalability nowadays. And these are the platform which are for managing the chain of operations that you want to do in your modern data warehouses. So these are some popular tools, but those are not limited. There are a lot of tools, but these are the ones that those are popular nowadays. So this slide I just purposefully put it to just give an idea, like if there is a concept of big data or data analyst or data science, like they use the data warehouse. But what level of knowledge or expertise, or what sort of function or languages they are using. So now the technology also changed, the data has also changed, the way that we interact with the data warehouse also changed. But the one consistent thing that is still live is SQL. So SQL is a very popular language. So without SQL, you cannot enter in the field of data. So whenever you want to go and become data science or analytics, machine learning, or going into data engineers or in the big data, so to knowing the SQL thoroughly, like, should be very helpful for you. So I'm just giving an example. So rollup is one of the function that Oracle has. So or a cube, or maybe the grouping set, the dense rank, partition by, or windowing function. So these are very popular functions. So every day, like all these data scientists, machine learning engineers, they are using it. So these are the advanced SQL concept, um, and doesn't matter whether I'm using the Oracle, or doesn't matter I'm using the AWS SQL or from the Microsoft Azure or anything. They always have the SQL API to interact with your data. So SQL is very popular things, and you should know about it if you want to enter in any of development or testing or anywhere. The SQL will not be an optional thing. So I can talk about the careers in a big data. So there are so so I mean the big data is a concept is now like it's now a routine concept now, and a lot of companies are also migrating their data from traditional database to the cloud one, and that's the reason all these different roles are gaining a lot of popularity nowadays. And also same timing, we are moving in the era of AI and ML and cryptocurrencies and cyber securities and all those. So we need a lot of expertise in terms of analysis there. So all these AI, ML, and big data engineers, those jobs are getting popularity nowadays. So a general trend, as I working in this field, and I'm working in the USA, and USA is a leading um, country in the whole planet when there is a question come for any new researches in IT field. So these are the popular, like some job opportunities everywhere, or every company is looking for. Uh, if you consider the users of data warehouse or data lake, or anyone that is close to your executives or any stakeholders, so that's called as a brain to your company. uh, then it's all about like data engineers, data scientists, and data analysts. So they work in hand, and they work interact with uh, uh, on daily basis to derive an actionable and helping a lot of stakeholders for their decision making. So these are sort of concepts. So remember one thing, like, so all these new things, new technologies will come, but the concept will remain same. So concept of data warehouse, concept of data lake, concept of data mart, ELT. So these are the concept. So the concept, we should be very, at least we should know about the concept, and with these new tools, you can implement that concept in the reality. So whenever I would see this data fields, I always like recommend to um, anyone that always try to gain the knowledge, or good knowledge on these terms, why these terms are being used, because these are the concept. The new tools will come, the old tools will go away, but the concept will never die. So the cloud computing concept or cloud data warehouses, so those will be remain same for a couple of years from now. So you should be at least reading those and trying to understand more, like why we are using that, what is the benefit out of it, what are the stakeholders, whether it is expensive or not, what companies are using it. The Netflix, they have a lot of video content, so they are using the cloud data warehouses. They're using the AWS stack, like that. And that's conclude my at least presentation on the data warehouse. So I'm happy to answer your any questions, or if you want any suggestions, and definitely, yes, feel free to ask me any questions now.
Students, if you have any questions, please ask to sir. So he will be able to answer your questions. You can unmute your mic and you can ask questions to sir. Any leads? Sir, actually, I have a question
Sure.
that yesterday, as it discuss, as held the discussion with you, you were telling me about Google Look BI tool.
Yes.
Can you just tell me about that thing? Google Look, how does it work, and can we do any, I mean, career opportunities with respect to that tool and all?
Sure.
Hmm.
So Google, they are going in. They are developing. They already develop a lot of cloud tools. So the cloud databases, the cloud editor, as well as the cloud repository. So and they also develop the cloud BI tool. Yeah, so it's called as a Google Looker. I'm still sharing my screen, right? Yeah. Yeah. So it's called as
Yes,
a
sir.
yeah, it's called as a Looker tool that they have developed. So this tool has a capacity that it works very well with the big data. So and it's connect with your any cloud platform, and it has a capacity to do some sort of programming and the visualization as well. So this will be a popular tools, one of the popular tool in the field of whenever you want to do the analysis on the big data side, because there is tools also like Tableau or Power BI, but those tools are work very well with the enterprise data warehouses where you have the data structured format. But this tool has a capacity that it can run with your um, uh, denormalized data sets, or where your data size is so high, or your data is in like very like low granularity, so it can work very speedily. And they also providing some sort of training. So this is a sort of a new tools. Only thing is here is like they do not have a lot of help available in online. Yeah. So right now in the Comcast we are using this tool, and I'm working on this tool as well. So it's a very uh, effective and heavy computation. It helps you to derive a lot of conclusions, and you can put a lot of different dashboards and visualization in the one single page. It doesn't have any limitation on it. Did I answer your question or?
Yes, sir. So I have one another question. So
Mhm.
what does this mean by operational data store? That is ODS.
Yeah.
I have
So
some question from my student.
sure. So ODS is nothing but the OLTP again. So OLTP, which is primarily
Okay.
used to uh, store the data for operational purpose. So it can be anything. So it's nothing but the another nomenclature for OLTP.
Okay.
Yeah.
So whether ER diagram helps us to take a way to the data warehouse?
Yes, because no one gonna give you a job in the data modeling directly. So in
Okay.
my career, like when I started, like I started with a programming analyst, and
Okay.
then I became a ETL developer, ETL
Hmm.
tester.
Hmm.
I worked in the mainframe side a little bit, and slowly I moved
Okay.
towards the data modeling.
Okay.
So, what does the data modeler does do? So the way that we design the OLTP, so which has the tables and relations and primary keys and surrogate keys and a unique key and
Yeah.
reestablish the relation, all these things. Where in the
Okay.
OLAP, we do not have those concepts. So we have the
Okay.
dimension that is across, and we need to create a measure. So we need to join all those dimension independently. So that's the reason it's called a
Okay.
dimension modeling. So, but until and unless you don't understand the ER, you don't understand the
Hmm.
dimension modeling. So dimension modeling is to design the data warehouse, and ER is to design your OLTP.
Okay. So what does this surrogate key mean?
Okay, so surrogate key means like uh,
Is it like a
whenever
primary key only?
you see it can be primary key. Use the primary key, but
Yeah.
that's a reference to the another tables.
Okay. 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 So can you just tell me the difference between ER modeling and dimensional modeling? How these two modeling help us to get into the data warehouse?
Sure. So again, the let me open the things if I have it. Maybe I give this example here. I have one another example. Um, okay, so is this visible for
Yes.
my
Yes.
screen?
Sir.
Okay, so now think about this is your OLTP, right?
Okay.
So when you do the any sort of transaction in
Hmm.
ATM, so your data instantly need to be get updated. A single mistake happen, your data will be bad data will go into database, and that will damage the relationship and that will damage the business as well. So for
Okay.
example, I withdraw the money and some negative
Hmm.
value went into the data, then whole things will be in a loss, right?
Okay.
So so in the ER modeling, very important that all these related tables
Okay.
has the relation. As soon as I updated anything, that will do the constraint check between all these tables, and immediately they updated everywhere.
Okay.
But in case of but and why I need this? Because I need a faster response. I need a faster read, write, and update operations.
Okay.
Then I need a ER. So this
Okay.
is transactional data that I need a few second decisions. But in case of the OLAP,
Okay.
my data is not transactional. My data is
Okay.
historical now.
Okay.
So if it is taking like 1 day to update, it's fine. And even the size of the data is also huge here, because here I'm going to store maybe up to 1 gigabytes or maybe up to 2 gigabytes, but here I'm going to store in the petabytes or maybe more than that. So uh, so so the conclusion, right? So when I see this data, like I always see as a relation, but now I want to consider like couple of different dimension all together. Then I want to go with the data warehouse where I have some sort of publication that I posted, and that's where it's very important for a data modeler to design to do the good dimension modeling based on the business. So if it is you are in a finance business, so what is important for finance? If you are in maybe like Comcast, like my company, so my company like owns the Universal Studio. They owns the internet in 16 countries. They owns the Sky TV or Tata Sky, those things. And they also own that. So for this company, they have the customer base, and the product base is very important for them. So our data warehouses are developed based on that. So whatever the company that you are, they are working, or what is the product-based company that they are in, they develop their own subject areas. So what is important for them to uh, take the decisions, and based on that, they design the data warehouse. Because each single data that is get generated, you are not going to store that.
Okay. So last only one question I have, that whether metadata and data dictionary both are same or the both are different.
Okay, that's a good question. So data dictionary is a part of metadata.
Okay.
So metadata is a huge term. So metadata, that is, so the data dictionary is tells you the information about all your like DDL languages and everything, right?
Okay.
But metadata also tells you from start to end. So what are these systems? What are they have? What is the frequency of the job? What is the computations? And then what is the hardware configurations and everything? So that metadata can be on Confluence pages. Some data is in your data warehouse. So it has different format where you store that.
Okay. Okay. So the means first way is to have a first we need to have a knowledge of database first to be a data warehouse analyst in the future. First we need to have that knowledge must.
Yeah, so whether you go for any big data role or whether you go for any programming role or anything, so database
Hmm.
is a prime thing. Whether you are become a mobile developer,
Yeah.
the again they have the mobile database. So
Okay.
database is a thing that everyone should know. There is no other
Okay.
alternative for.
Okay.
Now, if you
Okay. Okay.
desperately or you are very interested to go deeply into data science and everything, then for
Okay.
you need to learn the additional concepts and the additional
Okay.
technologies that can facilitate. I mean, that can enable you to interact with all those cloud databases.
Okay, sir. Okay. Uh, okay, sir. Students, do you have any questions? Can
Yes, ma'am.
anybody?
Uh, Hello, sir.
Yep,
Bhagyashree Holkar is here.
yep.
I want to ask you, like, being a fresher, how can we start our career with data analyst or data engineer? With when we have having a good command on queries like SQL commands and
Mhm.
that thing. How can we start? Is there any kind of certification over there, or we have to buy? I mean, textbook knowledge only.
Okay, so there are two things I can tell about this one, right? So the data engineer and the big data engineer. So there is a difference. Then data analyst and the big data analyst. So there is a difference, but their concepts are same. Now, what is the best suitable uh, career for you? So it depends on whether you are only interested in programming languages, then it's a data engineer. So where data engineers develop data structures, they are do develop a lot of machine learning models. They do establish the data pipeline. So they need to do the coding. So that coding is in maybe in the Scala, Python, or Java. Whereas when you want to become a data analyst, then you need to learn some additional skill set. So statistic, mathematics, and the BI or visualization skills. So you need to learn the BI tool, and you will be very thorough in SQL, and you should be able to like run any advanced functions in SQL, and as well as you know about the database and data warehouse and everything, and you also have to gain the good product knowledge. So it depends on your interest and the strength. You can choose that career. So now about the certification part. Yes, there are good certifications. So IBM offer a good certification in data analyst, and as well as there is a certification from Google. It's called as a Google Analytics 4. So that is also one of the good certification to do. Uh, so whenever you do the certification, when the analytics terms that it covers from end to end. But if you want to like focusing on a data engineer, then I think doing the AWS suite from the big data side would be ideal. And then to learning good programming and the object-oriented concept and data structure would be definitely would be the thing that can definitely help you more.
Yes, sir. Then AWS certification will be considered all the data warehouse concepts.
Can you little bit loud? I barely hear you.
uh, in AWS certification,
Yep.
all the points like we are covering in data warehouses that will be covered in that certification also, or we have to do some other courses also.
Uh,
AWS certification.
yes. So interesting part is like So AWS is cloud computing. So the concept I just now told about the data warehouse and dimension modeling and all those, there is no certification, there is no resources much available. So because these are the concept, and for AWS, it will cover the modern data warehouses or modern concepts in terms of the big data and everything. So as long as you have read by yourself from the traditional data warehouses and why we go to the cloud computation, that will suffice. And for certification perspective, AWS will not cover in detail maybe, but they are covering in detail around the cloud computing and whatever the services they have.
Like deep knowledge of cloud computing.
Yeah.
Thank you, sir.
So yeah, so one thing is like when I started career, like that time it was just Oracle. There was no concept of cloud that was not popular back in 2010. So now this cloud computing concept came and it changed everything. So when I joined this Comcast, like that time I used to install Oracle client. I used to install the dbeaver, just another tool to interact with the SQL. Then I need to install the Hadoop, HDFS, and all those setup. But now industry, like any new beginner, they just need a laptop and the browser, because all the databases they can interact through the online. They don't need to install any client. If they want to do the coding, they have the notebook called as Databricks notebooks. Uh, I can show you as well. So nowadays industry they so this is one of the company, they have the this concept called as a notebook. So you can code it in the browser itself. You can code it in the like Scala, Python, or you can write the SQL. So so we are going in that era. So it's a better way if you do the AWS and try to get hands-on on those sort of few technologies. That will definitely gonna help you, at least if you're targeting the big industries. So yeah, so Google Colab, I think you might have aware about this Google Colab thing. So Google Colab, they have the it's a cloud version. So where you can start coding in different languages, and as well as the Databricks also you can something that you can explore. Um, and then Jupyter Notebook is another one. If you're targeting for data scientist or big data engineer anything, so these three things definitely gonna help you a lot.
Yes, sir. But what I'm seeing right now, there is no
Mhm.
any kind of openings for fresher in data engineer, data analytics, or that things. So
Yes.
firstly,
Mhm.
what we have to start, like as an developer, or as you have done a product analyst, right?
Mhm.
So what we can start with our career to go and higher position of data analyst and that kind of thing.
Sure. So uh, why there is no position directly for freshers? Because all these technologies that we're talking about, AWS, Google's, and all those cloud competition, these are expensive. So not a single industry out there they can afford that technologies. So only the big shot companies or the product based companies, those can afford those technologies. So definitely they are not going to give a chance to the fresher to come and work on those technology directly. And these technologies need some sort of experience. So now, uh, but you can, as a junior, you can apply for big data engineer role, where you should be very good in programming, data manipulation operations, and you are good in your data structures and maybe Java or Python. So Python is a very popular language, something that you can definitely think about. So at least if they accepted you as a Python developer, or they accepted you as a database engineer, or they can accept you as a data engineer, that would be a good start. And then you can slowly move towards your career into big data and cloud computing. Or another way, if you want to become a data analyst or product analyst or maybe business analyst, you can start with the ETL developer. So you can learn maybe like Informatica or any sort of like ETL tool, then SQL. So that will push you in a data warehousing developer or BI developer role. or you can learn about any Tableau or something. So at least that's going to be like some good BI developer jobs you can get into, and then you can learn this concept and change your career path. So as your experience grow, then they're likely to know because that person can easily pick up the new technologies and he can definitely work on it.
Basically, we have to done some development part, then we can go this. So basically, we have to done with the development part, right? So can we start with the backend development?
Yeah, absolutely. Absolutely. Until and unless you're confusing and you're not getting job, right? It's ideal way to start with what are your strength in, right? Because now all these technologies, they always have the overlap. So I started my career as a Java developer.
Okay. Okay.
So, but I was not liking my coding. So I slowly moved my career into a database side. So I again and
Yes.
again asking my manager, like, can I go in the database or like, so they put me for as a Informatica developer. And before that, they put me as a ETL tester first. But all these different things, they push me towards like I got a lot of interest in the data warehouse and cloud computing, and that's where like I mold my career in that way. Uh, and as you're interested in like in certification and on all those things, like if you're doing by yourself, definitely those gonna be pushing you or like pushing you to that path. And the good thing about the new technologies, like they have the overlaps, whether you coming from testing background, automation testing background, or business analyst, or mobile engineer, or just Java developer, you have some sort of thing to do in a cloud computing way. So it doesn't matter as long as you're getting job and getting into industry. That's gonna be head start.
Yes, a last question.
Mhm.
Being a fresher, we have to start our career with MNC companies or startup companies, which will be better.
Okay, so I started my career with the Cognizant. Was my first company. So it's one of the prime company in India. So they have a lot of workforce. So means like they have the work to be distributed among the team. Where the startup company, they have the resource limited resources. So one resource has a lot of responsibility to take on. And I think both these things has a pros and cons. So if you're very dedicated that you're very certain that you want to go in specific field only, then these MNCs will not give you that thing right away. If any startup is there, they are giving you the chance with the low salary, but the technology that you really wanted to go in, I will go in that. But in a both the scenario where like I can get the job in anywhere, but the technology is of not of my interest, uh, then I would go with the maybe MNC, because that's where the MNC can support you for your higher education. MNC can support you to do a lot of certifications, and maybe you meet the people with the variety of the knowledge. So it's easy for to switch in the MNCs. So I will look my purpose. So, but if you really want to desperately want to become a mobile engineer or maybe the data analyst, and any company is giving that role, I definitely compromise everything and I'll go there.
Yes, thank you so much.
Yeah,
I'm
those
done
are the
from my
great
side.
questions, by the way. Yep. I remember when I started career, those are the things very confusing for me as well. So I accepted a Cognizant job as a Java developer. I started that because I got recruited as a on campus. I started working with the Cognizant. Along the way, I got to know like, hey, this thing is of not, I'm not liking it. These are the things that is always of my interest. So I started uh, uh, gaining more knowledge, interacting with the people who are working in those industries, trying to get the resources. And now this online thing, right? The knowledge share is very easy nowadays. 2010 and 2000, before 2015, it was so difficult for us. But now there is a Udemy portal, so they are giving you I mean, they are giving you the data science course for 600 rupees, and that's going to be self-paced. Then there is a Khan Academy. Then there is a IITs or I think central government. they have their programs called as INTC or something like that. So they are running. So there are a lot of knowledge, but getting a right roadmap,
Yes.
that's
Okay.
always come from the people who are in that field. And whenever you go, like, you try to look for mentor. So try to find out the mentorship, like who can interact with you and who can guide you very well.
Correct. Yes. Thank you so much.
Yep.
Sir, I have two questions. It is
Sure.
asked by Darshan Karekar in chat box. His question is that, sir, what will be the salary we can expect as a fresher if we opt to be a data analyst?
Okay, good question. Unfortunately, I don't know the salary range in India. Um, I can talk about in the USA. Like, USA generally depends on, so data analyst. So anyone can become data analyst. Even if anyone from the pharmacy background, he can also treat himself or herself as a data analyst, provided that he's working in the pharmaceutical analysis side. So it depends on, we are from the computer background. We always get, at least here, trained is around 50 lakhs something in USA. I'm not sure about the India, but there are a couple of websites that you can easily guess in.
Okay, sir.
The Glassdoor is one good website that you can definitely refer. So whichever company, for example, let's say Amazon, right? So you can search for Amazon, you can put the location and you can put the designation. It will show you the histogram or the bell curve. What is the minimum salary you can get with this company, with this role, at this location, with this experience. And it will give you the max salary, and as well as you can expect a more salary. So it will give you the good trend line there.
Okay, sir. Thank you. And another question, it is asked by Manoj Nesrikar. Sir, what is the difference between data scientist and data analyst?
Oh, good question. Yep. So, uh, so data analyst, what it does, like data analyst definitely help uh, to understand the data warehouse. First thing, understand the business, interact with the stakeholders, get their questions, and based on that question, he goes and see whether we have that data available. He join a lot of table together and get the meaningful insight and create the visualization and do ad hoc analysis as well. So, for example, uh, we have the voice command into my TV. So I was asked the question like, "Hey, tell me how many users who ordered the pizza through the voice command." So what for this question? So these sort of questions are coming from maybe what executives or some random question. So data analyst plays a very important role there. So he become a business analyst for stakeholder. He become a data expert to analyze that question and divert that and transform that question to the what he wanted to fetch from the data. He go to the data and check whether that data is available. So he become a data expert in that term. Then he become a data based developer, I mean data developer, where he define the lot of manipulation queries. He extract the result, he analyze that, then he become a BI developer and he visualize that. So that is the data analyst end-to-end cycle. So now about the data scientist. So data scientist is the one level up where you have a complex problem to find out and you want to use the machine learning or you want to use the data mining algorithms. So that's where the data scientist will come. So where they use the heavy statistic function, and they also do some sort of prediction analysis. So they develop the machine model as well. So they develop the rules based on the statistics. So for example, as I told you, like the market basket analysis, or um, so for example, if I go to the store, how likely that customer can buy the second thing as well. So these, the model, if they want to develop, then the data science will come into picture. So data science is just one step ahead than the data analyst. So where the data analyst don't do a lot of predictive analytics, but he do a lot of prescriptive analysis, maybe for the reporting, exploratory analysis, and all those things. He doesn't develop a lot of machine learning model. Whereas the data scientist, he always develop machine learning models. He used the machine learning skill set. He try to automate and deploy the models in the system that can create a self analytical decision engineering engine. So that is the basic difference. Actually, their skill set is different, and their purpose, the way that they interact with the data and the stakeholder is different.
Okay, sir. Thank you. Last question. Recently, we are seeing the news that a recession will come in IT field. Why it is recession means at this time?
Okay, so this recession trend is always there. So back in 2008, back in 2011, maybe 11 ending, some sort of recession come. So what happened in the COVID days? A lot of people forced to work from home, and their expenses capacity went little bit down there. So people were not, like, they went in a saving mode. They were not buying a lot of things in the market, and that's where whole cities, small businesses go and collapse. So whole this cycle is dependent on each other. So during COVID, all these companies, like, they sort of find a resource crunch. So they started giving a lot of good packages. So many people, they left the companies, they joined the new companies. So now when the life is become normalized again, the company is not in a mood and they are not able to, like, sustain the heavy packages that they have given during the COVID. They are not able to, like, things, and the investment they have done during the COVID, and when it now the everything is now normalized, they are not getting the business as usual. Their whole prediction maybe messed up. So now these companies are going in a sort of cost saving mode. And few
Okay,
companies I
sir.
know, yeah, few companies I know, like, they
Uh,
were hired heavily, so they were not having the jobs to do it.
okay, sir. Means it will not. So why are students are tensed nowadays by seeing that news, ma'am, recession is coming? How about BCA? I mean, if we complete BCA, whether we will get good job or not? They have that confusion. So try to just to clarify that confusion.
Oh, okay. So this specific recession, I would say, that happen only for people who are getting paid very high.
Okay.
Or during the COVID, whatever the people, they change the job for the sake of a good amount of money, and now company don't want, so they are kicking them off. So don't worry about if
Okay.
you're a fresher. So you're gonna get the normalized salary.
Okay.
So it's gonna be value. I mean, it's gonna be helpful for company because they want to, like, fire the people who getting for them, like, they're paying a lot. So
Okay.
I think you will be good. I mean, you're gonna get the good salary, so you don't need to worry about it.
Okay, okay. Is actually students were tensed because of that only because of that recession news. So only thought of asking that question because again after this they may some may go to job, some may go for their higher studies. No, MCA, whatever things, MBA, MCA, whatever they want to pursue that one. So only just I was in need of clarification of that one.
Yeah, I don't think so. For the junior, it will impact more. It's must be impacting more for the higher level people.
Okay, sir.
Mm.
Okay, sir. Thank you. Now we will wind up this session.
Sure.
Thanks for your valuable time. What is the time there in USA, sir? Now?
It's 2 a.m. in the morning.
Oh,
I'm in
okay, sir.
EST time.
Okay, okay. Means in Indian Standard Time it is 2 a.m.
Uh, Indian, what is that? Sorry.
What is the Indian time? Actually, we are having right now. Time is 12:22. Now, what is your time there in USA?
So it's a night. I mean 2 a.m. So I'm
Okay.
10 hours and 30 minutes behind the Indian time.
Okay, okay, sir. Thank you. Thank you for your valuable time. Thank you for guiding our students, sir. Hope once you come to India, visit our college, sir, so
Yeah,
that
absolutely. Yeah.
students will interact more with you.
Okay. Yeah, absolutely. Yeah. If anyone of your student has any question, I mean, feel free to drop in LinkedIn. I'm
Yes,
always
sir.
there to help. Yep. Thank
Yes,
you
sir.
so much for
Just
inviting me. Yep.
okay, sir. You just share that LinkedIn profile to me through my WhatsApp. I'll share to my students so that they will get they can post their queries to your LinkedIn profile.
Sure. Yep. I'll do that. Yeah.
Okay. Okay, sir. Thank you, sir.
Thank you guys. Have a good
Yeah.
one.
Good
Yep.
night. Good
Bye.
night. Good night, sir. Bye.
Yep. Good night.